Hi, welcome to the Study Point Coaching Center. Today's topic is electric field and lines and flux. Let's get started. First, we will understand what is an electric field. An electric field is the physical surrounding created around a point charges. It is a physical surrounding that is created around these point charges where another charge, this one is another charge, it experiences force of attraction or repulsion. Mathematically, it is defined as a vector field associated with each point in space representing the force per unit charge exerted on a positive discharge, that is E equal to F upon Q. This is the main formula of the electric field, right? Now, we will calculate the field of a point charge, that is electric field intensity. Electric field intensity at any point in the space consider a point charge q. Here point charge q. To find the field at a distance r at the position of p, we place a small test charge, that is plus q naught. According to Coulomb's law, the force of attraction or repulsion between them will be F equal to 1 upon 4 pi epsilon naught q naught upon r square. If not, it is capital Q naught upon r square r cap. Electric field is defined as the force experienced per unit positive discharge. So, electric field will be F upon Q naught. Now, substituting the value of F into this formula, we get get 1 upon Q naught multiplied by 1 upon 4 pi epsilon naught. Capital Q naught upon r square r cap. Now, this Q naught and Q naught will cancel out, and hence we get our final formula, that is to be known as E equal to 1 upon 4 pi epsilon naught Q upon r square r cap. Alright. Now, since electric field is also due to the force of attraction or repulsion of a point charge, so if there are multiple charges, then the net electric field at any point is the vector sum of the individual fields. This concept is known as the principle of superposition. The forces are assumed vectorially, considering both magnetic magnitude and direction also. तो क्या होता है? Let there are multiple charges, like here is Q2, here is Q1, here is Q3, here is Q4, and so on. Due to these charges, the electric field at point P will be the vector sum of all these due to all these charges. Means we can say E net will be vector of E1 plus vector E2 plus vector E3 and so on, vector En. Substituting each field we get 1 4 5 not. What will be the value of E1? It will be Q11 R1 square, R1 cap, Q2 upon R2 square, R2 cap, and Q3 upon R3 square, R3 cap, and so on. Finally, the derived expression will be E net equal to 1 upon 4 pi epsilon naught times sigma Qi upon Ri square Ri cap, where I is the integer value, that is 1, 2, 3, 4, 5, 6, and so on. Welcome back to the study point coaching center. In this part, we will study the electric field lines and flux. Now, our first concept is that what is electric field lines? Actually, electric field lines are the imaginary curves where the tangent at any point indicates the direction of net electric field. Net electric field at that specific point. Electric field lines provide a visual way to map the vector field configuration around the charges. इलेक्ट्रिक फील्ड लाइन क्या करती है कि हमें एक विजुअल वेव प्रोवाइड कराती है, एक मैप उसकी जरिए से हम ड्रॉ कर पाते हैं, जिसमें हम ये कॉन्फ़िगर कर पाते हैं कि किसी भी चार्ज के अराउंड जो फील्ड है उसकी इंटेंसिटी कैसी है, किस डायरेक्शन में है ना, और कितना फोर्स कोई वहां पर चार्ज रखता रहेगा तो वो कितना फोर्स एक्सपीरियंस करेगा ना, लाइक विजुअली इलेक्ट्रिक फील्ड लाइंस पैटर्न्स जो हम ड्रॉ करते हैं वो कुछ इस तरह से होता है कि इफ देयर इज अ सिंगल पॉजिटिव यूनिट चार्ज देन द इलेक्ट्रिक फील्ड लाइन विल start from charge to the infinite, and if there is a single point negative charge, the charge will the electric field will start from infinite to the charge. Means for a positive unit charge, the electric field lines are radially outward, and for a negative unit charge, the electric field lines are radially inward. But if there are two point charges, that is one is a positive charge particle and another is negative charge particles, we see this configuration of electric field lines for two opposite charges. We see here two the field lines go from positive charge to negative charge. All the field lines are going from positive charge to negative charge. What are the important properties of electric field lines? Electric field lines always start from positive charge and end at negative charge. If there is a single charge, they may be start from charge particle and end at infinity or vice versa. Means if there will be positive charge, the electric field line will start from charge to infinity, and if it is a negative charge particle, that is minus q, the electric field lines will start from infinity towards the charge. In a charge free region, lines are continuous. It is a very important point that in a charge free region the lines are continuous. These are continuous without breaks. They have no breaks. कोई breaks नहीं. The two field lines can never cross each other if it would imply two directions. ऐसा अगर क्या होगा, अगर दो इलेक्ट्रिक फील्ड लाइंस एक दूसरे क्रॉस कर जाएंगी, तो इसकी वजह से क्या होगा, हमें इलेक्ट्रिक फील्ड लाइंस की दो डायरेक्शन मिलेंगी, एंड दैट इज नॉट पॉसिबल. इलेक्ट्रोस्टैटिक लाइंस नेवर फॉर्म क्लोज लूप्स. Electric field lines never forms closed loop. This is also an important property, because you can see here this field line arises from positive charge to negative charge. But below this, here also, this field line also start from positive charge to negative charge. If we see these lines, they are moving this way, but and if we make close curve, they should move like this. इन्हें ऐसे मूव करना चाहिए, but they are moving like this. Means they are not close curves. Alright. तो ये रहा आपका इलेक्ट्रिक फील्ड लाइंस की प्रॉपर्टीज के बारे में, कि हमेशा इलेक्ट्रिक फील्ड लाइंस क्या होगी, पॉजिटिव चार्ज से स्टार्ट होगी और नेगेटिव चार्ज की वो एंड होगी. और इफ देयर इज सिंगल चार्ज और में इफ इट इज पॉजिटिव चार्ज, the electric field line will start from charged particle and end at infinity. If it is negative charge particle, then the electric field lines will start from infinity towards the charge particle. And also, the charge free region, in a charge free region, lines are continuous curves. If there is no another charge, it is charge free region, the lines are continuous curves. These are continuous curves, okay, they are no breaks. And also it is very important point, and ये पूछा भी जाता है आपका, इससे रिलेटेड क्वेश्चंस आपसे पूछे जाते हैं. Why two field lines can never cross each other? Two field lines एक दूसरे को क्रॉस क्यों नहीं कर सकते, है ना? तो if they cross, it would imply two directions of one field. तो इससे क्या होगा, एक ही पॉइंट के ऊपर क्या होंगे, एक ही फील्ड की दो डायरेक्शंस हो जाएंगे, एंड दैट इज नॉट पॉसिबल. हेंस two field lines can never cross. Okay. Electrostatic lines never form closed loops. कभी भी closed loops फाइंड नहीं करती हैं. अभी मैंने आपको रिप्रेजेंट करके दिखाया. This property is due to the conservative nature of electric field lines. ये क्या शो करता है? It shows the conservative nature of electric field lines. Okay. Thank you. Now we will study another topic, that is electric flux. What is the concept of electric flux? Electric flux measures how electric field lines passes through a surface. Electric flux क्या करता है? ये measure, it is a measurement. किस बात का measurement है? कितनी electric field lines किसी surface से pass होकर के जा रही है. This concept is the key in understanding how electric fields interact with objects. एक ऐसा कॉन्सेप्ट है जिसमें अंडरस्टैंडिंग क्लियर होती है कि कैसे एक इलेक्ट्रिक फील्ड लाइंस इंटरेक्ट होती हैं विद ऑब्जेक्ट्स, एंड इट्स फंडामेंटल टू गॉसेस लॉ. और इसके अंदर अभी हम एक और लॉ पढ़ने वाले हैं, दैट इज गॉसेस लॉ, स्टडी करेंगे. उसमें इनका क्या रोल प्ले होता है. वन ऑफ द कोर प्रिंसिपल ऑफ द इलेक्ट्रोमैग्नेटिज्म, जो कि क्या इलेक्ट्रोमैग्नेटिज्म का बहुत ही एक कोर बहुत ही प्रिंसिपल. Now, mathematically, what is the definition of the electric fields? Electric flux. Electric flux is the total number of electric field lines passing through a given area. It is per unit time. Electric flux is the total number of electric field lines passing through a given area per unit time. Per unit time में जितना भी किसी एक सरफेस से या किसी भी एक एरिया से जितना भी इलेक्ट्रिक फील्ड लाइंस पास होती हैं, उस अमाउंट ऑफ इलेक्ट्रिक फील्ड लाइंस को हम क्या बोलते हैं, इलेक्ट्रिक फ्लक्स बोलते हैं. इट इज डिनोटेड बाय a Greek letter that is phi, and it is the dot product of electric field line and area vector. Now there are three cases found regarding electric field lines. इलेक्ट्रिक फील्ड लाइन से रिलेटेड आपके क्या है, थ्री cases formed. First one, when the surface is just perpendicular to the electric field line, then the theta will be theta, the area vector. Area vector क्या होता है, जो सरफेस है, सरफेस के किसी भी सरफेस के परपेंडिकुलर जो भी लाइन हम ड्रॉ करते हैं, उस लाइन को हम क्या बोलते हैं, एरिया वेक्टर. जस्ट लाइक दिस वन है ना, यू नो दिस वन इज एरिया वेक्टर. And if it is this area vector is parallel to the electric field line, then the flux passing through this surface will be maximum. And if it makes this one is electric field lines, direction of electric field lines, and this is area vector, and here is an angle that is theta form, then the electric flux passing through it will be phi equal to A dot A cos theta, A multiplied by A cos theta. Very important feature. And if area vector is 90 degree to the electric field line, it is 90 degree, then cos theta will be 0, hence phi, the value of flux will be 0, means there will be no flux passing through this surface. This surface will be thus pass out. That is the very important point. Now for the maximum flux when theta equal to 0 means the area vector and electric field lines both are parallel. Okay, for zero flux theta must be 90 degree. Now what is the unit of electric flux? The unit of electric flux is voltmeter or Newton meter square per coulomb. There are two units of electric flux, that is voltmeter or Newton meter per coulomb. Newton meter square per coulomb. Okay. Thank you for watching video. If you like my videos, please like and subscribe the channel and also hit the bell icon. Thank you.